Hello, welcome to Global Online, and here we are discussing NTA UGC NET 2023 Paper 2 Economics, and today we are discussing about distributions. And there are mainly three types of distribution: binomial, normal, and Poisson. In this video, we are discussing binomial and normal, and later in next video we discuss about Poisson distribution. And distributions are the important categories that deal with data sets. Before we moving ahead, a quick look at what Global Online offering for you. We provide full syllabus video lectures, notes, mock test, and last 10 years PYQs. Those who have interested to join with us, please contact with the given WhatsApp number. It will really help you to crack your exam. Okay, then we move to our session. First, we discuss what is the distribution or what means the distribution is. There is an example is given. When you roll a fair die, die means 1 to 6 outcomes are there and the probability of getting these outcomes are uniform. That means 1 to 6. There are definite set of outcomes in there. So distribution is an important part of analyzing data sets which indicates all the potential outcomes of the data and how frequently they occur. So here uniform distribution is the equally likely events. That is unlike Bernoulli distribution. It is the next category of distribution and we discuss here uniform distribution set. Here all the n number of possible outcomes of a uniform distribution are equally likely or it have happened in one of the outcome, that is 1 to 6. So when you toss a coin, here that same case happen, that when head or tail will come as the outcome. Okay, and this possible outcome we also use in the business context for forecasting the happening of events, understanding the success or failure of outcomes, and predicting the probability of outcomes is essential to business development and interpreting data sets. And we deal with the shape of uniform distribution curve is a rectangular shape. Here we can see the shape is rectangular, so the portion is called rectangular distribution. The uniform distribution is also called rectangular distribution. Whenever you hear rectangular distribution, you can remember that is uniform distribution or the events are equally likely events. And A and B here is the positive parameters. Okay, positive parameters, we deal with the positive parameters in earlier video. So those who have interested to watch that video, please check in our channel. Okay, and that is types of distribution. In normal distribution, there are three mainly distributed components, that is normal, binomial, and Poisson distribution. Okay, first one, normal distribution. Normal distribution in modern digital workplace, business need to rely more than just pure instinct. So today's world, there will be more digital analysis. So for this analysis, we use this distribution. Normal distribution is also called bell curve. You know that the bell-shaped curve. It's a bell-shaped curve. Okay. So this is normal distribution. It's a peak point and this is starting point and this is the later point. Okay, is broadly utilized in statistics, business setting and government entities such as FDI. Okay, so this distribution is also called bell-shaped and is widely recognized as being a grading system for tests such as that we can connect with the graduate students rating high school or GRE. Okay, and normal distribution contains following characteristics. First characteristics, it occurs naturally in numerous situation. It happen naturally. It doesn't have any other means of occurring. Okay, so naturally numerous situation happen to occur normal distribution, and also the data points are similar. The case of die we can see 1, 2, 3, 4, 5, 6. The cases are similar and a small range. Okay, and then there are a low and high ends. In data range there are low and high ends, so it's a small a range and also occurring in naturally. So it's a key terms, naturally occurring and small range and low and high ends of data range. These are the three important characteristics of normal distribution. Then the formula. Here the formula is given z equals. So z indicates normal distribution. It's an important point. And then z equals x minus mu divided by sigma. Sigma, small letter sigma. Okay. This is the capital letter sigma and this is the small letter sigma. And the x indicates a value that is being standardized. Here standardized means the higher value in the outcomes. That is 1 to 6. We can write the value, that's a standardized value is 6. So here x equals 6 in case of die. In mu, mu means the mean of the distribution. So here the mean of the distribution is indicated in mu. And sigma, small letter sigma, is the standard deviation of the distribution. So mean in mu and standard deviation in small letter sigma. Clear? And then we can give the values to the equation, convert a raw data. We study raw data, discrete data, that we deal in next video or in the upcoming videos. Okay. Raw data value x to a standard score z. Standard score z means here the z indicates a normal distribution. Okay, and assuming 4 and 2. For example, in finding the probability for being in a die, tossing a die, and here the 6 is the standard value. Whenever the 6 resemble, the formula will also change. And the z score corresponding to x equal to 6, that will be z is the normal distribution, x is the standardized value, that is 6, and 4 is the 4 indicates the mu. Mu is the mean of the distribution and 2 is the sigma, small letter sigma, standard deviation. Clear? So here 6 minus 4 by 2, the value is equal to 1. And whenever the value equals 1, that means x equal to 6, which is one standard deviation above the mean. And here the standard deviation is above the mean. Okay. So x equal to 6 indicates here. That is, the equation is standardized. Whenever z equals 1, that is a standard deviation above the mean will indicate. So we can easily find the standard deviation and also the normal distribution value from here by getting the values of x, mu and sigma. And next, binomial distribution. Binomial distribution. For this, we can also relate with business application. The normal distribution we can relate with this with a business standard or in the business situation that can be utilized for model risk and likely to outcomes for certain events like the amount of next month's revenue from a specific service. We can analyze what we can get from next month revenue or what is the profitability of the firm. And also we can use in the operation management that sometimes normally distributed as the employee performance, human resource management, and human resource management applies normal distribution to employee performance. So these are the situation though we can use normal distribution for getting the profitability or for the future period and also for the human resource management. and the process variation in operations of management. Okay, I just relate with this binomial distribution. And the binomial distribution is the a case of likelihood of a pass or fail outcome. In normal distribution, we relate with a numerical values. Okay, but in case binomial, sorry, normal case, we relate with this numerically 1 to 6 or 1 to 10, that's etc. And in case of binomial distribution, we relate with a likelihood of pass or fail outcome. That's a both chance, pass or fail. And in the experiment replicated numerous times, it can be experimented numerous times. So the value will get changed. There are two potential outcome, that is true or false, heads or tails. Here the case of tossing a coin come. And then the characteristics of binomial distribution. First variable, the number of times an experiment is conducted. So the number of times the experiment is conducted indicated in the first variable. Second variable is the probability of a single or a particular outcome that performed trials have any effect on the probability of the following trial. So first we toss a coin, we get a head, and then we toss a coin, again we get a head, and after a numerous number of tossing, at the 10th toss we get the head, tail or head, maybe any case. So the following trial will also affect by the previous trial. So the second variable indicate the effect of following trial with a previous trial. Clear? And likelihood of success is the same from one trial to the following trial. It doesn't any partiality or any happening of bias here. Okay, first variable indicate the number of trials, and second variable indicates the effect of following trial with the previous trial. Outcome, none of the performed trials have any effect on the probability of the following trial. Here there is no effect is written. Okay, none of the performed trials have any effect on the probability of the following trial. So here that says likelihood of the success is the same from one trial to the following trial. Here there is no any bias. Next case, the equation is given as a very large equation. Don't get panicked by seeing this equation. Here the P equal to X equal to small x equal to C. Here C, N here and X here. N indicates the case of failure and X indicates the case of success. Combination of events happens here. And P raised to X into 1 minus P and N minus X. So simply we can get this is the case of happening. Number of success is returning here, that is small letter x, and number of random variable in x, capital letter X. Here also the cases of success are taken. From this success, C is the combination of X success from N trials. We toss the coin for 10 times and we get 4 times. 4 times we get head, and later 6 times we get tail. And we find heads are the success and tails are the failure. So we get a 4 times success and a 6 times failure. So combination of X success from N trials. From 10 toes we get 4 combination of success. Okay, that is indicated in the C. And P raised to X is the probability. It's a chance of getting success. And 1 minus P. P is the success, and from P we reduce the P from 1, we get the probability of failure. Okay, that's a 4 times success. We get it from 10 times of tossing a coin. So here 10 minus 4, that is 6. 6 is the chance of getting or the case of failure. Okay, n minus x is the number of failures. So n minus x is the number of failures indicated here. So here we can get the point. P is for pass or success and n is the case for failure. So written here, number of success, random variable, and random variable means any variable that can be get from the tossing or any other situation events from the data. Okay, combination of x success from n trials that we done in C. Probability of success, number of failures, and probability of failure, that is n minus p. And then also the business application of binomial distribution. Here the binomial distribution, we can use it in situation of banks and other financial institution. We can use binomial distribution that to determine the likelihood of borrowers defaulting, that is not paying the amount back by the consumers or the loan holders to the bank, and apply the number of towards pricing insurance. In case of insurance, we can also apply binomial distribution and figuring out how much money to keep in reserve. How much money we can keep in reserve also find by getting a idea about binomial distribution and or how much to loan. So these are the cases we can use the binomial distribution, and in normal distribution we can use in the situation of human resource management and also in business cases, that is how much profit or the profitability of the next month or the future period. These are the following points or the business condition, business application that we can get from both of the distribution. One is normal and the other is binomial. So that's for the day, and we let me conclude this session. So any doubts regarding to this portion, please put it in the comment box. And also the later distribution, that is Poisson, and also the Bernoulli distribution. This is next category. So today we discussed about uniform distribution, that is equally likely cases, that two distribution, binomial and also normal, both the distribution deal with the equally likely cases, and Poisson also deal with them this case of uniform distribution but with a different instinct. So that we discuss in the next video. So study well and also keep watching videos. Thank you.